Yeah, so we're going to talk a little bit about Khepri today. You unfortunately stole my joke about the RabbitMQ Summit, so we're going to be talking a little bit about RabbitMQ as a kind of use case, but really this is just an introduction to Khepri and how you might be interested in it for things on the Beam and how we're using it to replace Amnesia. So before we even really get anywhere, I just want to say hello. So I'm the Mike Davis, the one and only, if you've ever seen me on GitHub. I first started in the Elixir world, so if you've seen projects like Mint WebSocket or Slipstream or Spear, that's me. And about a year and change ago, I joined the RabbitMQ core team, and since then I've been working almost exclusively on Khepri. And if you didn't know, the VMware team, or VMware employs the whole RabbitMQ open source team. So that's why there's all this VMware decor everywhere. And then when I'm not in the Beam world, you may have seen me in the Helix text editor, which I help maintain. So we're really just going to be talking about three things today: Amnesia, which you've probably heard of; RabbitMQ, which you may have heard of. There's a summit next door if you'd like to check that out. I'm sure there's lots of knowledgeable people who can tell you all about it around. And then we'll be talking a little about Khepri. So to start with Amnesia, Amnesia is just built straight into OTP. So if you have Erlang installed, you've got Amnesia, and it's an application and set of modules for persisting things in memory, on disk, or in memory and on disk. And it's just like big collections of records. So if you've seen like ETS tables, it's like a big wrapper around ETS and DETS with a whole bunch of extra features on top. It's kind of an oversimplification. And it's got some nice things like you can make these schemas, and you can have these big tables with indices. It supports transactions. But really one of the main features that we're going to be talking about is how it can replicate your database tables across multiple nodes. So if you've got multiple Erlang nodes talking to each other, you can configure Amnesia to share some tables across these nodes so that your data is just kind of everywhere. And the last thing about Amnesia that I'll say is that it's quite performant, which is a tough thing to say generically, but what I mean by that when I say it is that it's not really that much overhead compared to ETS and DETS. So it's kind of tough to beat in terms of replacing it. So Rabbit. So Rabbit is actually an Erlang project. GitHub is very confused about this fact, but I've corrected it for you all here. It's the entire broker is written in Erlang, and then the CLI tools are written in Elixir. So it's a nice Beam project. I'm going to try to explain in 2 minutes exactly what a broker is, but really, with the RabbitMQCon next door, do take a look at that. RabbitMQ.com is also a nice place to find out about it. Basically, it's a broker, and so that means that if you have like this big backend where you've got a bunch of services talking to each other, you probably don't want these services talking to each other just directly through something like HTTP because it can be pretty brittle. So the idea with a message broker is that it's a kind of middleman. It sits in the middle of all of your services, and your services talk to that middleman instead. And so it has high availability. Things talk to it. And that is, again, an oversimplification. Rabbit supports a lot of things. There's cool things like streaming and stuff like that. And you can do some very cool use cases like connecting edge devices to it. And then those edge devices push messages to Rabbit. And then other services can consume out of that and do some processing and push things back to Rabbit. So that's the basic idea of it. But it does use Amnesia under the hood. So when I say that it uses Amnesia, I'm not saying for all data generally, but there is a bunch of metadata. So what we store in Amnesia and Rabbit is any sort of metadata. So this is like definitions of queues, definitions of users or vhosts or things like that. And it's not going to be things like messages, right? We have specialized storage for that for performance reasons. And eventually we want to replace Amnesia in Rabbit with Khepri. So Khepri is our project for doing that. Again, it's all Erlang, no NIFs or anything odd like that. It's an Erlang library, so you can pull it in from Rebar, from Mix, whatever you like, and it's going to fulfill a very similar niche as Amnesia. So we're using really the same way that we use Amnesia in the broker. So we're looking at in-memory and on disk. So data is stored in memory for performance, right? So you can look things up quickly, and on disk, so that if somebody kicks the plug out of your Rabbit, then you don't just lose all your data. It has some very nice QOL things to sort of mirror Amnesia, like transactions, so you can do things atomically. But again, we're really going to care mostly about replication. So the replication in Khepri is done via Raft. So Raft is very difficult to explain in 2 minutes, but I'm going to try. There's actually a fantastic talk from 2018 from Carl Nilsson, who I think is in here somewhere, filled with info and emoji about Raft and RabbitMQ Raw. So RabbitMQ Raw is our Erlang library for implementing Raft, and so Khepri is just kind of a thin definition of a Raft machine built on Raw. And so the basic idea of RAW is it's a distributed consensus algorithm, and that sounds very fancy, but it's actually very easy to understand. And the whole real point of Raft is that it's supposed to be easy to understand. So I'm going to try to glide through it a little bit, but do check out some extra resources if it interests you. So basically, you have two ideas that you really care about. You have a distributed, or you have a replicated log, and that log is basically just like a big list of commands. There's extra metadata stuff going on in there, but in terms of Khepri, this might be something like put, right? You want to put something into the tree, or you want to delete something out of the tree. These are each commands, and the idea when you build the tree and over all these commands is that you're basically folding through it or reducing through it if you're familiar with Elixir, so that you end up with that state. That's the idea of state machine. It's not really like genstatum or genfsm or anything like that. It's just kind of like an apply. The way that you make this replicated log is that you have a single leader that you elect, right? So you have all of your members, you've got all of your rabbits, and they all elect one of their members to be the leader, and they do that by a majority, or a quorum. Once you have that single leader, that leader is responsible for writing new commands that come in from all sorts of clients all over the cluster, wherever they are. They go through the leader and get appended to its log, and then its job is to replicate, or to send its log to all the other members, and then once entries from that log have been sent to enough members and those members have acknowledged it, you can say that that log entry that's been confirmed by a majority, a quorum, is committed, and then you can apply it to the state machine, right? We can update our tree with that command. So I wanted to show a little bit of the basics of Khepri, just the kind of hello world in Khepri. The basic idea is that you start up a store, and a store is not really like an amnesia table, it's more like it's its own tree, right? So we're talking about in memory and on disk, so you give it a disk where you can persist to. And then we can do some basic operations. So at first look, this looks a whole lot like a key value store. You've got a put operation here. You're associating this stock wood oak thing with 200, and then you can get that key back out. But it's a little bit more fancy than that because Khepri uses a kind of tree-like data structure to store everything in a kind of Zookeeper style. So if you're familiar with Zookeeper, it's similar to Zookeeper, but without all the extra Zookeeper features, it's really just more of the tree. So in this case, we've got the root, and then we've got a stock branch, a wood branch, and then an oak branch, and we're associating that 200 payload with oak, and so we can use atoms and binaries. So if we were to look at that like a tree, we've got that here. And with different put commands, we could attach that data anywhere else. So we're just attaching it to oak here, but we could attach it to stock or wood. And so the data structure that we're using here is really a prefix tree, or a trie, if you're familiar with those. A little bit more of fancy stuff about paths and path patterns. So line 6 here is showing off a Unix path, which is just a kind of, I don't know, convenient format to write paths in if you're like working in the shell or something like that. We've got stock as an atom, looks very elixir-y. Wood as an atom, and then birch gets converted to a binary, and we can associate values with that. It's really the same thing as the list, just a little bit more convenient. But the real power comes on line 7 with path patterns. So path patterns are a way of describing a kind of set of paths that are possible in the tree, and we can use that to query into the tree, fold over things, check if nodes exist, count nodes, and do things like that. So here we're getting the paths and payloads associated with stock wood star, where that star is a kind of wildcard that gives you all the branches below stock and wood. We can see our oak and birch from the prior lines. Transactions. Yeah, I just wanted to give a quick example of these. You're transacting over the store rather than a table or anything like that. So here, everything is done atomically, so we read, we double the value, and we write, and because it's a transaction and it's atomic, there's no way that some other process can come through after we read, write something, and then we would overwrite the value. That can't happen. Either we do everything at once or nothing. But the basic idea of a transaction is just that it's an anonymous function that's executed on the store. As I said, it's just a regular Erlang application, and that means that you can use it from Elixir pretty easily, just as any other Erlang library. And we've even got some extra goodies in there. If you're familiar with like the Elixir bang functions, you can use put bang and get bang, and these will raise errors instead of wrapping things in OK tuples. So now we've seen a little bit of an intro of what is Khepri, and now we should probably ask why Khepri. So I think Khepri, we've been working on it now for probably like 2.5 years was when the repository was created. We've had up to 3 engineers working on it at a time. So why make this big investment into Khepri and try to get rid of Amnesia? And really the thing that we don't like in Amnesia is the replication algorithm, right? I said that we would talk about this more. What we really like in Khepri is Raft, and we really want to pivot away from Amnesia's consensus algorithm because it, I don't know, it isn't very nice to work with. So there was a nice talk yesterday called Hyperamnesia where we talked a little bit about if you have a sort of split brain or a network partition scenario where you have, say, two rabbits and they can talk to each other, and then you have a third rabbit that's part of your cluster, and maybe the network gets kind of disconnected in between, suddenly that rabbit is on its own, and if you have things trying to make changes to the metadata store on that rabbit, and things trying to make changes to the other metadata stores on the other two rabbits that can talk to each other, eventually they're going to kind of diverge, and then when they reconnect, they're going to be very confused about what to do, and the Amnesia user guide basically says, that's up to you. That's not really something that should be solved by Amnesia itself. And so we really wanted to get rid of that and have something that behaves very consistently and coherently when we have those when we have those faults in the network, because Rabbit is very established, maybe old. It's been deployed anywhere and everywhere. It's, I think, 12 or maybe even more years old, and it's it sees these things all the time. They're not just theoretical concepts to Rabbit. They do happen, and so when they happen, we want to be able to reason about the system in a way that makes sense. And so you might think, well, why not just try to fix Amnesia? That we actually tried that first. So we had a little project called Amnavis. And Amnavis was basically tear out the internals of Amnesia and replace it with Raft. And it actually got pretty far. It had an integration branch, but ultimately we just binned it because it was just way too complicated, right? We were toting around these complicated parts of Amnesia, kind of fitting Raft into it in a very weird way, and so we just wanted to start over with something fresh with Khepri, and go something that can just lean directly into Ra and Raft. You might also ask, well, why not just use Amnesia everywhere or something like that? Well, we have other features that do consensus, like quorum queues, and there's some coordination for streams that also needs to use a consensus algorithm somehow. And using the one from Amnesia is not straightforward at all. I don't know, you'd have to kind of crane lift it out of there. And so being able to build those things on Ra and have the same dependency used to build every machine makes a lot of sense. And it's also just a whole lot simpler. So at the end of the day, if you see like the Ra example for a key value store, it's just a super short machine, very easy to understand, and it passes Jepsen tests and all sorts of things that we care about consistency-wise. So that's why Khepri. We've also seen what is Khepri, and so your next question might be when Khepri. This thing sounds great, when can I use it? And it actually just got merged into the broker about 2 weeks ago, and there's a new release candidate that just got released yesterday, today, depending on your time zone, that you can open up and use Khepri from then. Khepri is also, of course, a standalone library, so you can download it. We don't really plan on making any big changes. We've got a couple of smaller API changes that we're working on. But feel free to just use it and give it a try if that's something that you're interested in. You're trying to get Amnesia out in your own code base. So once you have the 3.13 release candidate, you can pull that down, and it first starts with Amnesia enabled. And so if you've got a cluster already going with Amnesia, you just keep running 3.13. And then there's this feature flag where you can say enable the Khepri DB, and everything will get migrated over, and then you'll just be using Khepri. The eventual plan is that we just want to get rid of Amnesia eventually. I think we have to go through some phases where I think in 4.0 we want to release so that Khepri will be the new default for new clusters, but you're going to continue to use Amnesia if you need to, right, if you're already using Amnesia. And you can see from the size of this pull request that it was quite a sizable effort. 14,500 lines up, 1,500 lines down, and this is really not even the only PR that was working on this. So the first step, as I was saying, Rabbit is quite established. There are a lot of places in the code base where things were just calling Amnesia directly or calling ETS directly to get at Amnesia tables. And the first step really was to pull apart that code and have some nice APIs around the database. So now we have modules like RabbitDB users, RabbitDB vhosts, and RabbitDB bindings where you can go in and list things, update things, delete things. And then this PR, all it really did was update the tests a whole bunch to make sure that we're testing both Khepri and Amnesia, but also add that adapter for Khepri so that we're using that in all the appropriate places. Yeah, there are a couple of advanced topics. I don't want to tread on the question space too much, but I did want to give some teasers. These could be, I don't know, blog posts or long talks on their own. But there's two things in it that I really like in Khepri that I think are a little bit more low level and advanced that are also interesting. The first is projections. So you might be wondering, well, how does Khepri compare to Amnesia performance-wise? It is, at the end of the day, kind of just a process that's sitting there, and so querying it is going to be very slow when you compare it to Amnesia, which is just making calls against ETS tables. So projections allow you to sync a path pattern in the tree with an ETS table. So you give Khepri a path pattern and an anonymous function that lets you map between those paths and payloads and put them into an ETS table. And then you can query directly out of the ETS table, and it's Khepri's job to keep that ETS table up to date and give you all the consistency guarantees that you need there. This is what we use in most of the broker for performance needs when switching over to Khepri, and so a lot of the features in the broker, I don't want to say all of them because I know I'm going to get a Slack that says that there's some feature that's a little bit slower that needs to be fixed to look at, but just about everything uses projections to achieve, if not the same speed as Amnesia, maybe a little bit faster, maybe a tiny bit slower, because at the end of the day, both of them are basically just calling ETS. There are some places where projections are really nice, though. For example, topic exchanges. Since it's not just a view of the table, we can like purpose build these projections so that we can set things up so that now it's not an ordered set and we're reading from it and selecting. Instead, we can just read by key out of a set, and so we get actually much better topic exchange performance when we're routing in that once you switch on that Khepri flag. The other project, the other small part of it is actually split out into its own library, RabbitMQ Horus, all this on GitHub, so if you want to check that out. This is actually how I initially got interested in Khepri, and it's the way that transaction functions work. So transactions are a little bit special with Raft because when you submit that transaction command, first of all, you need to be able to persist it to the log, so it needs to be something that you can write to disk and read from disk and turn into a term somehow. And also, there are different guarantees about how it's going to be run. So transactions in Khepri are run, I think, at least once per member, because they need to be run on all of the members to make sure that all of the members reach the same state, right? They're folding through that log, and so they have to fold through those transactions and each execute it. So you can't do things in these transaction functions like send messages, do I/O, networking, randomness, or anything like that. And so we need these functions to be pure. And so this is what we do for that is we take a look at these transaction functions, we decompile them into the Beam ASM. We look for any instructions like sending messages that are bad. If we don't see any of those, we look at all the calls. We see if those calls go anywhere bad, like inets or something like that. If all of those calls look okay, or if we don't understand what those calls are, we go and recursively decompile those and look at the Beam for those. And then once we have all of that big Beam tree of everything down to the built-in functions, we can recompile it all into one big module, and that module is the transaction function. So that's what Horus does, and it's kind of linting, but also preparing a Beam module that we can put on disk into the raw log. So yeah, that was Khepri. So quick recap of it: Khepri is our tree-like persistence that we're trying to bring in to replace Amnesia and RabbitMQ. There's a new RC out today/yesterday, so if you want to give it a try out 3.13 RC1. And the main takeaway that I really want you to take away from this is that it's replication by Raft instead of whatever Amnesia is doing. Thank you.
Cool. I think we maybe have time for a question. Yes.
Yeah, maybe you were speaking very quickly, so maybe I missed it. But what happens if the transaction fails? So for Raft, you were by yourself, say, you don't have consensus, you try to write. What's going to happen then?
Yeah, so transactions, well, they can kind of fail in two different ways. So they might fail if I don't know, you make some sort of assumption that something will match in the transaction function itself, and that might not be true. And that just means that that transaction will be aborted and none of the changes will be made against the tree. Otherwise, it might fail. You might fail if you don't have a quorum, right? It might time out while you're trying to submit the command before it can be read or before it can be written. And in that case, that's just a totally different kind of error. So those are both errors that you would get from the Khepri transaction function, but they are both just shapes that you can match on in the error handling.
Then you have to retry or something.
Yeah, the retry is left for the client, so it's not something that is kind of blocked on or anything like that.
Cool. That's the time we have. Thank you, Michael.